Okay, today we're talking about stretches and shrinks again. So here it is in words if you'd like to read through that. I'll pause for a second. Okay, so here is the way I would summarize it for you. If you have something on the inside, by now you should know that that's an inside, like left-right thing. Do you get that? That's a left-right thing? And what word goes with left-right? If you're going like this with your hand, what's that left-right mean? Horizontal, like the horizon. Okay, so that's, I also like to use high-vo. High, hold on, alignment's off, so I gotta write bigger. High-vo. Horizontal on the inside and vertical on the outside. Okay, so this is on the inside, so it's a high thing, and therefore it's horizontal. So is that a horizontal stretch or a shrink? You gotta think it through. On the inside, can you trust it? No, can't trust it. So therefore, it seems like it's 3 times wider. In fact, it might actually be, in fact it is, 3 times narrower. Okay, so if you wanted to say it officially, would you please write it with the correct words? Use the word horizontal in your answer. What was done to this one? And in a moment, I'm going to ask you to turn it my way and show me. A minimum of 3 words and then 1 fraction for your answer. Correct, sir. Yep, yep. The factor is off. Your factor's right. Your factor's wrong. Your factor's right. Yours is right. Yours is right. You can't just take the factor they give you. It's usually, if it's on the inside, it's the opposite of what you would think. So, yes, 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 yes. Horizontal, shrink, factor, not 3. Factor what? 1/3. Okay, good. And if I go like this, now it's been moved, what 3? Down 3. How about this, when I throw a negative in front of it? Is that an up-down or a left-right thing? It's an up-down thing, also known as vertical. It's a vertical what? And then flip is not the official math word. Vertical reflection, yes. So if it had these 3 things to do, there's 2 correct orders that you could put them in. 1, 2, 3, and 1, 2, 3. I'd like you to write out the 2 correct orders they could be done in. If you can't figure out 2 correct orders, give me 1 correct order. This would be first, this would be second, this would be third. The reason there's 2 is that I've given you 2 things that can't both be true at the same time. I've said you should start on the inside. Do you remember that? Okay, and I've also said you should start with reflections. Stretches and shrinks should be first. Do you remember that? Because it's multiplies, and multiplies come before add subtracts. So if you're going to try to follow both those rules, you really got to do it in 2 different orders. So if I really start on the inside, I would say that the 3 on the inside would be first, and that means you would do a horizontal shrink factor 1/3 first. And the second thing you would do would be to go out here and do it in the normal order of operations. That's first and that's second. So that would be a reflect, and it's up, down, so it's a vertical reflect. And then the last thing would be down 3. The other option would have been to start on the inside. Wait, to start with the reflection. Okay, so this could be done of the 3 things. This, and this. This could be done first because it's the reflection. So that'd be a vertical reflect. And then number 2 could be go to the inside. Oh, wait. No. Yeah. I think you probably thought that. You probably thought I should do the... actually, that's a shrink. No, that's right. That's right. That's right. This horizontal shrink factor 1/3. And then the last thing is the down 3. Notice the down 3 is last in any scenario. Okay. Any other questions about order? All right. Let's get into the actual smartboard here. Actually, there was a page I skipped over. I want to get to, not that one. Okay, sorry. This is the one I want. Describe the transformations. We just talked about these first two, but this one's a little weirder. Why? Yep, it's y over 2. How do you fix that? Multiply by 2. So if I multiply this by 2, that just goes away. And multiply this by 2, the 2 goes in front. I hope you know that. Now, if I multiply both sides by 2, this is a really common mistake, what I just wrote there. How could that be wrong? I'm supposed to multiply by 2. Yes? Yes, you are correct. Because when you are multiplying by 2 on both sides, you're taking an equation and you're timesing by 2. You have to times by 2 everywhere, including that last number. Okay, so now this is y equals 2 times the square root of 1/4 x is the way I'd like to say it. X over 4 means 1/4 x. And then the last one is minus 1 times 2 is 2. There. I bet that would trip a lot of people up. Forget to multiply this by 2. But if you multiply an equation by 2, you multiply everything by 2, all the terms of it. Okay, so here, how would I start to get this cleared up? Anytime you have a fraction, you should clear those fractions. So yes, you multiply by 5. Now, some people get confused on this, that should you times this by 5 and times that by 5? No. Because why? Because this is all one term that's being divided by 5. And then when I multiply by 5, it's going to cancel that off. This other side, do I multiply everything in here by a 5? No. That's all one term. That whole thing, it doesn't have like a minus 1 on the outside. So it's all one term. It just gets times by 5 once. That cancels that. Now I have y plus 4 equals 5 times the square root of 2x minus 1. And then I subtract 4 from both sides, minus 4. This is gone. And there's my answer. 5 times square root of 2 times the quantity, x minus 4, or x minus 1, and then minus 4. And then what order would you do them in? All right, I'd like you to take a second. There's 4 things happening here. Try to do them in the right order. 1, 2, 3, and 4. Use words like reflection. Use words like horizontal and vertical. If you get this, we're almost done, really. You just got to actually graph a couple and then... Mr. HM, tell me how to start. I'll give you a choice. It's either this or this. You know why? Because there's stretches and shrinks. All right, we can start on the inside. That's always generally good advice. And in this class, we're okay with you doing your stretches and shrinks first. When you're done with that, you can do your moves. So, of the two, if you're about to do a flip and you're about to stretch, in real life, in gymnastics, which one should you do first? Stretch out first and then do the flip? Yep. All right, this one doesn't have any flips and it's just stretching or stretching, so it really doesn't matter. Okay? So your 2 stretches have to happen. One is a horizontal stretch. And is that really a stretch, though? It's actually a shrink. So Mr. M, tell me again. Horizontal shrink with factor of what? This is the horizontal one I'm doing right now. That's on the inside. But since we're shrinking, there you go. Okay, good. Now try the 5. Good. Good. Factor 5. You got it. How come you can trust it when it's on the outside? Because it's on the outside. And you can trust stuff on the outside. And then the last thing, you do it from the inside out, and you'd have right 1 and down 4. How many of you had that right? All right. That's a tough one, because the order is what kills everybody. All right. When you graph them, the order is important. Do the stretch or shrinks, and then do your reflections. Actually, this is kind of funny. The teacher who wrote this does it differently, I believe. Well, these all can be tied with each other in value, but I do like this to be first and this to be second. Stretch before you flip. Okay? But technically, all of those are technically tied with each other because they're all multiplies. They're all multiplied by this, multiplied by a -1, multiplied by a fraction. They're all multiplies, so it really doesn't matter. And then the moves, the translations, the slide it this way, slide it that way, those are always last. Okay, if we're going to graph this thing, could you make an XY chart and then just graph those points? Absolutely. Could you graph the parent and just move those points around? Absolutely. Which way do you want to do? I don't know. It's up to you. Okay. But I will tell you that the best is both. The best, in my opinion, is use both methods, because then you can check yourself. So I'm personally going to do it by starting with the points that are graphed here. So everybody graph those points, if you haven't already, the parent points. And then we're going to do them, and we're going to do them in the right order. Remember, I can't just move that to the right 3 right away because I know it's going to move right 3. You'll be getting it wrong if you do that. It's very likely anyway. Sometimes it doesn't matter what order you do a problem in. Sometimes it does. But we always should do it in the right order just in case. So you just had a slide that told you to do all your multiplies, those stretches first. So we should stretch it first. So now, the height of this guy right here is not going to change because his height is 0. The height of this one is a height of 1, so it's going to move. Everybody do all of the stretching on that and make it vertical stretch factor 2. Be with me. I got 2 people doing 2 different techniques here. Some of you guys are snipping the points and moving them, and that's totally fine. Others of you are making 2 sets of points with different colors. That way's fine too. I like both. All right, so I'm going to do this 2 sets of points with different colors motif. And this is over 2 and up 4, and I change it to over 2 and up 8. So now if you can focus in on those black points, you may be able to see that compared to the red ones, if I were to connect the red dots, it's now been stretched up, and the black one is kind of looks like a rubber band that's been pulled a little tighter than the other one. It's twice as tall. Now, a parabola, it's hard to really see the tallness of a parabola. All right, but you can tell each point, that one's obviously half as tall as that, or this one's twice as tall as that. And then the last thing is we've got to move the thing. We're going to move it right or left. Right 3. So your final answer should be 2, 3, basically there. See if I can get my red graph out of here because I don't need that anymore. Oopie. This is moved over 3. I'm going to grab each of these points, move them over 3. There we go. There we go. It's done. If you only had 8 questions, which is reality, pretty typical test, you get 1 free mistake on the front and the back, and then after that, every extra problem you get wrong, you lose a whole grade for, go down from an A to a B? Do you get how you're probably going to make one dumb mistake because you're human? So then that means every time you have a problem like this, on the test we're going to take in about a week, a little less, every time you make a mistake on a problem, you lost from an A to a B. That's a huge thing. Most of you guys get A's and B's. Would you rather have the A? If you'd rather have the A, you should check. How do you check? You make an XY chart, and you make a few points on that XY chart. So everybody, please, make an XY chart next to it. Now, what's a logical point to pick? Well, look where your graph is. It's over to the right a little bit. Would it be logical for me to check -2? No, it's not even on the graph. So I should probably check like maybe 3. But don't look at your graph to get the answer. Of course you're going to be right in your own mind. Put a 3 into this function right here, and then see what happens. I'd like you to check 3 points. Make me 3 points that are going to plug into this function right here. So if I stick a 3 in, I get 3 minus 3 is 0, 0 squared is 0, 2 times 0 is 0, 0, 3, 0. Does that match up with my graph? Yes. Now let's check another one. Mr. T, tell me another one I can check. Okay, I can put in a 2. If I put in a 2, tell me what happens. Walk me through it. -1. Squared is 1. 1 times 2 is 2. The answer is 2. 2 comma 2. Is 2 comma 2 on our graph? Yes. And as soon as you got a couple like that, you're probably fine. Let me do one more. If I put in a 3. Let me just put in a 3 a minute ago. 4. Put in a 4. If I put in a 4, 4 goes in here. 4 minus 3 is 1. 1 squared is 1. 1 times 2 is 2. 4 comma 2 over 4 up 2. I just verified those points right there worked. Now, do you get that I could have skipped the whole move it, flip it thing in the first place? I could have just made the chart. You can. You could just make the chart and then graph the points you get off your chart. And then it'll be in the right spot. For this next one, I'd like you to do that. Make an XY chart. Do not graph it and move it and flip it. Just make me an XY chart. Pick some numbers for X. Now be smart about it. You don't want to do X is 3 because you'll have to do the square root of 3 and nobody knows what that is. So pick smart things to put in for X. Yes? Okay, I'll pause for a second. You guys work on this chart. Try to get me at least 3 points, hopefully 4 or 5 points. XY table. Go ahead.
0 and 4.
If you stick in a 0, square root of 0 is 0. 0 times a half is 0. Plus 4 is 4. I agree with you. 0, 4. Raise your hand if you had that point on your graph. Okay, good. Let's see. Mr. A in the back left corner. Give me a point. You put in a 4. And if you put in a 4, tell me what happens. One step at a time. Square root of 4 is? Half of the 2 is? Don't you have to multiply first? Yeah. Now just walk through it with me. You said this was 2, and now we do half of the 2 is what? Add plus 4 makes 5. 4 comma 5. Raise your hand if you had that one right. Okay. Give me another point that's on there. Let's go ahead. Miss D. I'm putting in a 9 now. I see why you chose that because square root of 9 is going to work out nice. What is the square root of 9? And then you times it by a half, which makes 1.5, plus the 4 makes 5.5. Very good. Okay. Could there be other numbers? Yeah, but some of the bigger numbers that we'd put in there wouldn't work real nice. There's one other really nice square root people forget about. 1, you are correct. You put in a 1. That way, square root of 1 is 1. Half times 1 is a half. 4 plus a half, 4.5. And if I graph those points, you've got your answer. You don't have to graph the parent. You don't have to make it half as tall then. You don't have to move it to the down 4. It'll be there in the first place. So now you might like this way better. 0, 4, 4, 5. And, oh wait, 0, that's not 0, 4. What the heck? 0, 1, 2, 3, 4. 4, 5, 9, 5.5. Here's 9, 1, 2, 3, 4, 5.5. And the last one is 1 comma 4.5. Oh, 1, 2, 3, 4.5. Does this look like it's a ramp shape? Does it look like it's been moved up 4? Yeah. And the last thing, does it look like it's squished a little bit, half as tall as normal? Yeah. See, I just did it in the opposite order. I graphed it first with the points. Then I went back and checked it and said, does it look like it moved up 4? Yeah, here's where the ramp would normally be. It's up 4. Does it look like it's half as tall as normal? Yeah, normally when we go over 1, it's up 1. But here, if we have over 1, it's only up a half. So yeah, it looks like it's been, it's half as tall as normal. Okay, that's the process. And you get to pick. On this problem right here, for example, you would pick, do I want to graph the parent V and then do all of these things to it, or would you rather make the XY chart? I would bet that after a while, a lot of you would say, I'd rather just make the XY chart because it involves a lot less graphing it, then I move it, then I stretch it, then I do all of these steps. All you got to do is plug a few numbers in. Like, what's an awesome number to plug into this one? It'll make everything go away almost. A 2. You see why? Because if I put a 2 in there, 2 minus 2 is 0, half of 0 is 0, and then it's minus 4. 2 comma negative 4 is on my graph. I know it. I think it's easier to do it this way than it is to graph the parent and then try to remember the right order and everything. Do you get that I don't have to remember the right order as I do this either? I just have to, like, know how to put a 3 in now. Okay, everybody put in a 3 and see what you get. So 3 minus 2 is 1. A half of 1 is a half. A half minus 4. Oh, I forgot the absolute value. Absolute value of a half is a half. And a half minus 4 is negative. So 3 goes in, and I get negative 3.5. It's another nice number to put in. I don't know. 4? 4 minus 2 is 2. 1 half of 2 is 1. 1 minus 4, negative 3. And I just have to graph those points. Then, though, if I do it that way, I should double check at the end that it actually looks right. 2, negative 4, along with 3, negative 3.5, along with 4, negative 3, all right, this is supposed to be a V shape. Maybe I should do one more point. Maybe I should do negative 1. Or maybe even nicer, negative 2. Negative 2. Negative 2 minus 2 would be negative 4. 1 half of negative 4 would be negative 2. The absolute value of the negative 2 would be 2. 2 minus the 4 would give me negative 2. Negative 2, negative 2. That spot's on my graph. Do you see? It's a squished V shape. Now, could you have done that the other way? Absolutely, and I don't care. You can do it either way you want to. You can either graph the parent, and then you'll have to do 3 things. Take all the points, make them, that's on the inside, so that's twice as wide. Make all the points twice as wide, and then you have to move it 2 to the right, and then you have to move it down 4. That's a lot of work. But it is also a little bit of a pain to have to plug in these numbers, like, you know, sticking in, you may have noticed I avoided negative 1 because then I'm going to have negative 3, and then I have to take half of negative 3, which would be negative 3 halves. That gets a little weird. Absolute value of that is 3 halves, which is 1.5, and 1.5 minus 4. So some of these numbers get ugly, but you know what? You get to pick whatever numbers you want. So if it's an ugly number, say, I don't like negative 1. That's not good. I'm going to try something nicer, like a 2. 2 would work easy. And maybe things I can take half of, like, let's say if I made this 8. 8 minus 2 would be 6, and I can take half of 6 easily. Half of 6 easily is 3, and then that's 3 minus 4, which would be -1. So, all right, you get to pick either way, whichever way you like, but that's the hardest kind that we have to graph. It's got a whole bunch of shifts and sometimes even flips. You got a whole bunch of things, and if you do them in the wrong order, you get the wrong answer. And let me tell you, this XY chart is your best friend. All right. Is that a cell phone? It is on my desk. Okay. So your assignment is right here, stretches and shrinks, worksheet B. And it says numbers 1, 2, and 3. So I want to see if that's sections 1, 2, and 3 or what. But your assignment is worksheet B, stretches and shrinks. And that's all I got for the video for today.